Greetings. My name is TipHudson. I work for Washington State University Extension as a range and livestock management specialist. We're going to talk a bit about grazing for soil health in both rangeland and agricultural ecosystems in the Pacific Northwest. Globally, grazing lands are approximately half of the Earth's land area. These support the livelihoods of millions of people. Grazing lands are typically less productive than agricultural lands, or they would already be in cropland, but grazing lands are extremely important because they provide a myriad of other ecological goods and services. Things like water storage, water quality, water flow regulation, clean air, nutrient cycling, wildlife habitat, carbon sequestration. Grazing lands may store as much as 30% of global soil carbon stocks. And grazing principles, as we'll see, may be pretty consistent across the different kinds of grazed land types, but there's some different big picture goals in grazing rangelands relative to others, and we'd like to talk about both. So we need first to ask what are rangelands. Historically, rangelands were defined negatively by what they were not. Today, the textbook defines rangelands as plant community types that are dominated by grasses and shrubs. Interestingly, in a recent book on the history of rangeland science, Dr. Nathan Sayre of UC Berkeley says that rangelands are probably more like oceans than croplands or forests, in that they are vast and variable and they resist micromanagement. And in fact, he defines them as, quote, non-forested places where more intensive economic activities have not yet taken root. This may be cynical, but it is accurate in the socioeconomic context of most of the world. In the Pacific Northwest, rangelands are most of what is left over if you exclude cropland and forest. But this view shows everything that has less than 25% canopy cover, so it does include grazing on forested systems. My point here is that grazing management has the potential to affect, for better or for worse, nearly 2/3 of the Pacific Northwest. We can affect through grazing management the soil health and carbon sequestration rates on a very large percentage of the Pacific Northwest. What I'm calling agroecosystems, on the other hand, are managed primarily for agricultural output and only secondarily, if at all, for other ecosystem goods and services. A literature review from a little over a decade ago indicated that carbon sequestration potential on semi-arid rangelands is pretty limited, but carbon storage is quite significant and it's globally important. And I'm mentioning carbon storage because it's a good indicator for soil health. Perhaps against intuition, recent research indicates that grasslands are a more stable reservoir for organic carbon than forests are, since grassland carbon storage is mostly underground and is much less vulnerable to release through fire than forests or true shrublands, where the majority of carbon is above ground in woody plant tissue. In the shrub steppe, approximately 80 to 90% of the organic carbon is stored in the soil. And again, this is a very stable pool unless it's disrupted by tillage. And about 15% of that, the carbon in the soil fraction, is considered active, which means it's subject to short-term change based on climate or management. That flux really represents the difference between photosynthesis and decomposition. So conserving rangeland carbon stocks is pretty dependent on, one, avoiding land use conversion, and two, ensuring that the short-term sequestration opportunities are fully realized, primarily through good grazing management. There are a number of biotic and abiotic factors that influence soil health on rangelands, and these interact with each other, making the big picture pretty complex. Climate and soil texture mostly drive the plant community type. Climate and soil also drive soil depth or limit soil depth, soil carbon potential, and related hydrologic features. In addition, the time since a given management practice has been in place really affects to what degree that practice has affected soil health. So we could distinguish between increasing soil health, and again, I'm using soil carbon as a proxy indicator, and maintaining existing soil carbon stocks. Light to moderate grazing on grasslands has been shown to cause significant increases in soil carbon as well as improvement in soil structure compared to heavy grazing. In fact, a 2016 study in the Great Plains found that improvements in grazing management over the last 50 years have recovered much of the soil carbon and nitrogen that was lost in the previous 50. And we're going to come back to what that kind of grazing looks like. But what specifically does what mechanism, ecological mechanisms does grazing affect, and how can we manage grazing to optimize these effects on soil health? Now, the grazing affects rates of plant photosynthesis. It affects the relative amounts of root material versus the above ground shoot growth. It affects how the plant allocates carbon. It affects the root mass and also plant root exudates that are important for soil structure and soil organic matter. I want to back up just a bit to talk about climate, and then we'll get back to grazing management. We tend to think of western rangelands as being characterized by aridity, and this is certainly true. There's a distinct precipitation gradient starting at about the 100th meridian, right in the middle of the Great Plains, which is hugely agronomically significant. West of that line, we find much drier plant communities that um, require different kind of management than what we see east of the 100th meridian. But the variation in precipitation from year to year and the variation in forage production then on non-irrigated lands is a much bigger driver of ecological change. This variability challenges what we have historically thought about stocking rates. And since soil health depends on the maintenance of perennial plants, especially perennial grasses, a few years of serious overgrazing due to overstocking in a year with abnormally or anomaly low forage production can undo years of carbon storage, and this has negative economic consequences, not just ecological. And there are some indicators that this variability may be increasing, which increases the need for adaptive management and flexible stocking. This graph is showing uh, forage production over about the past 35 years, going back to 1985 when the satellite data became available, and it shows the variation since that time from year to year. We see that variability increasing. And we can see this variability at home. Now keep in mind that this example of a June photo taken 4 years apart is not necessarily evidence of climate change. This is the natural variability that's inherent in Pacific Northwest rangelands since at least the last ice age. However, the concern is that the swings between the high and the low years could be more extreme, and that has a pretty good basis. But we can see from this next photograph that there can be a significant difference from year to year in total biomass production on the same site. Both of these photos were taken before there was any grazing on these sites. The variability is a large driver of rangeland change. So what are the conditions that we're wanting rangeland ecosystems to bounce back to or resist movement from? What are the plant community attributes that promote soil health and that maximize or optimize the amount of soil carbon that we can hang on to? Some specific plant community attributes that are important are species composition, the diversity of functional and structural groups. The diversity of these groups has been promoted as a really good indicator of long-term rangeland health. The relative proportions of different ages of plants is also important. If plants are not reproducing, then we don't have young plants, and the old plants senesce and will eventually be replaced by uh, perhaps less desirable plants. Canopy cover on the spaces between the rooted portion of the plant is quite important, and plant spacing is one way to describe plant communities and compare them one to another. All of these things are good, and we can identify specific problems that are associated with um, a malfunction in any of these plant community attributes. Well, when these things are being managed toward rangeland health, we experience lower soil bulk density, higher water infiltration, higher water storage, higher resistance to erosion at the plant soil interface, higher litter incorporation, which increases slightly soil organic matter, but probably more importantly, it helps to insulate the soil and provide some temperature amelioration. Attention to this, to cover as an indicator of health is not new. Uh, Back in the 1930s, in the aftermath of the Dust Bowl, scientists were pretty quick to quantify this inverse relationship between cover and soil loss. Soil loss is a first order problem. We can see from this really old research that where there was only 50% ground cover, meaning you had 50% of the soil that was not covered by plants, they were measuring 4 tons per acre of soil loss. That is a gigantic agronomic failure and an ecological problem. The mechanisms here, at least if this is grazing land, is that excessive trampling combined with really low residual plant material post-grazing results in decreased soil pore space, reduced infiltration rates, and less plant available water. Those factors drive a decrease in root and mycorrhizal growth. This impairs soil structure and decreases nitrogen cycling, and those things all reduce plant productivity. That then changes the plant community, which tends to exacerbate the soil problems, and we get this wicked feedback loop that results in precipitously declining soil health. I want to be quick to add, those are not the results of all grazing, just bad grazing. There's abundant research showing that changing from heavy grazing to light or moderate grazing rapidly interrupts that wicked feedback loop and begins to work the other direction. This is why carbon markets pay more per acre on degraded ground, because degraded ground under improved grazing management can rapidly sink new carbon as it builds back root mass, soil organic matter, and the annual biomass produced by mostly perennial plants. Caveat here, a plant community shift that increases shrubs increases the amount of soil carbon that's stored above ground, which again is vulnerable to fire. If we're going to try to repair something, you first have to know exactly what broke. So we need to acknowledge and characterize what I'm calling improper grazing. I like to say that this is how the West was lost. People that came to the West moved here mostly from the East, and the people in the Eastern U.S. came, most of them originally from Europe, which had more mesic plant communities that were dominated by sod-forming or rhizomatous grasses that responded really well to frequent defoliation. The bunch grasses that dominate nearly all of the western United States do not respond so well to frequent defoliation during the growing season. So what this a downward successional sequence could look like is that if the dominant perennial grasses are grazed during their peak of growth every year, which is in April, May, and June, and they're grazed too close to the ground so that they experience very little regrowth after grazing, and the soil is not very covered during the summertime, and if we have season-long grazing that results in animals grazing whatever regrowth does occur, then these perennial grasses are at a significant competitive disadvantage to anything in the landscape that's not being grazed, including shrubs or plants that resist grazing through some physical mechanism, or plants that are unpalatable. So we end up with a lack of new desirable perennial plants, lack of reproduction. The old plants senesce and fade away. The ungrazed native plants expand, and then we also get exotic species that increase both in density and extent across the landscape. So we can end up with sagebrush, cheatgrass, knapweed, and some native short grasses like Poa secunda that, uh, that tolerate close grazing. At this point, we've crossed an ecological threshold into a new degraded stable state that is undesirable. Stable meaning it's probably going to persist. I want to interrupt our regular programming with a short commercial about some case study videos that a group of us with the Center for Sustaining Ag and Natural Resources produced over the last few years. These case studies highlight three different aspects of rangeland management for soil health and rangeland resiliency. And I would encourage you to take a look at the website listed on the top of the slide and take a look at these 6 to 9 minute videos. They're worth seeing. Well, enough of what we should not do. What then do we do? I think all the principles I'm going to lay out here will apply on both rangeland and irrigated pastures, and I'll note a few differences as we go through. The first general principle is that stalking rate still matters. Stalking rate does not have to do with the relative intensity of management at a given point, either in space or in time. The stalking rate refers to how many animals we're allocating to an entire landscape over the course of a year. This is also not the utilization rate. Utilization refers to how much of the standing biomass has been grazed in a single grazing event. The stalking rate refers to how many animals we're allocating over a long period of time. The second general principle is that it's almost always beneficial to limit the duration of the grazing period. Whether we're talking about irrigated pasture, grazing cropland, or grazing rangeland, it's usually not a good idea to have animals in the same location for many months at a time. We might call this season-long grazing or multiple season grazing. Thirdly, on rangelands that are dominated by perennial bunch grasses, it's necessary to let the plants go to seed periodically. That can be accomplished by moving animals around the landscape. It can be accomplished by not turning animals in some years until after seed shatter. There's a number of ways that this can be accomplished, but the general guideline is that at some point over the course of a decade, these plants have to produce seed every once in a while. Fourthly, if at all possible, it's important to allow plants to regrow within the active growing season after they've been grazed, or at least in the next growing season before the plants are grazed again. And keep in mind that for most of the Pacific Northwest, at least in the Intermountain West, the growing season is March through the middle of July, roughly. And so it's not a good idea to graze plants for all of those months. A conservative stalking rate tends to result in light to moderate utilization, but this can also be just accomplished by observing animals and limiting the duration of the grazing period and adjusting when animals are using a given piece of ground. And this has been a significant shift in our understanding of plant physiology over the last 50 years. It used to be thought that plants stored a significant amount of carbohydrate reserves in the plant crown and the roots, and that as long as you didn't chew up the plant crown with grazing animals, that plants would be fine. That is not the case. We discovered quite a few decades ago at this point that the plants store what that plants have, grass plants have a relatively small amount of carbohydrate storage. And what they do store is mostly in the basal portion of the stem. And so these grasses need to not get grazed below about 4 or 5 inches um, every year in order for them to have sufficient uh, food storage to initiate growth in the next year. Keep in mind that extreme utilization also has economic consequences, most notably that if you push animals too hard, it can cause declining body condition or declining animal health. At a landscape scale, we expect to see quite a bit of plant material left behind after the animals have used a given site. And whether in irrigated pasture or cropland or rangeland, livestock distribution is still pretty important so that individual areas are not overused and other places receive some use. One general principle is that relatively minor shifts in management can have quite significant results. This is a side-by-side fence line contrast with livestock grazing on both sides of the fence. The grazing principles that I have discussed have been observed in the background of the photograph. And in the foreground of the photograph, you have a smaller number of animals that are present for a long period of time, resulting in persistent pressure on the most preferred plants. And this has consequences for forage yield, for soil health, for riparian health, for water quality, for water storage, for fish habitat, for upland habitat. It really is a pretty comprehensive change, and the only difference may be limiting the duration of the grazing period and being careful not to utilize the most preferred plants heavily. These things also translate into profitability for livestock producers. I think that many ranchers may feel like grazing in the way that I'm describing is leaving money on the table. And I like to say that it's more like having money in the bank for several reasons. One is that if we maintain a diverse, site-adapted plant community, especially on rangelands, what we get is high forage yield, high plant production. Further, if we maintain that kind of healthy plant community on irrigated pasture, in cropland, and on rangeland, we extend the amount of year characterized by active plant growth. And this has significant consequences for total forage production. And finally, animal health is maintained where the animals have access to a wide variety of plant species. Animals that are consuming a diversity of plants tend to have uh, better animal health, and we can define that by how much money is spent on pharmaceuticals for those animals. Animals are healthier when they have access to a wide variety of plant species and when they're not forced to eat low quality forage for a long period of time. These concepts and many others that are related are discussed in more detail at a podcast that I started a couple years ago called The Art of Range. You can subscribe through your favorite podcasting platform, or you can listen directly from the website at artofrange.com. And if you have suggestions for content or have some questions about material that's been covered on the podcast, I would encourage you to contact me directly by phone or email, and I would love to visit with you about it. Thank you.